6.4 properties of rhombuses, rectangles, and squares. Now, first we have to define what these are. And sometimes we'll get very frustrated because they have an idea of what these are, but you need to have these by definition. So a couple things. To what makes a rhombus would be if all four sides of a parallelogram are congruent, then it's a rhombus. So first knowing it's a parallelogram, then knowing that all four sides are congruent, that's a rhombus. If it's a rectangle, is a parallelogram with four, so all the same properties of a parallelogram are true for these, but also in a rectangle, all four angles are 90 degrees. If you have a parallelogram that is a square, that means all four sides are congruent and all four angles are 90. So this is where people get really frustrated and it's hard for them to understand because in a special parallelograms, we have rectangles, we have rhombuses, and in the middle we have a square, meaning every square is a rectangle. Every square is a rhombus, but not all rhombuses are squares and not all rectangles are squares. So looking at this first one, is this parallelogram a rhombus, rectangle, or square? Explain. Well, first when I'm looking at this, I already know it's a parallelogram. If it's a parallelogram, opposite sides are congruent. If opposite sides are congruent, that means these are the same and these are the same. If it's a parallelogram, which I know it is, then opposite angles are congruent. If it's a parallelogram, that means consecutive angles are equal to 180. So 180 minus 90 makes this 90 and makes this 90. So now, because all of the sides are congruent, all of the angles are congruent, this would be a square. We do also have special things for certain shapes. If a parallelogram is a rhombus, then the diagonals are perpendicular, meaning that when I draw my rhombus right here, and these are the same, these shapes give you a 90 degrees right here. So again, this chapter is full of properties, so that the diagonals are perpendicular. If you have a rhombus, then each diagonal bisects opposite angles, meaning this line bisects this, meaning this is going to be congruent to this, and this will be congruent to this. This one is congruent to this one. This one is congruent to this one, which is not always true for a parallelogram. So what are the measures of this numbered angles in this rhombus? It's telling me that this is a rhombus. So if this is a rhombus, I know that these two have to be the same because every rhombus is a parallelogram. So opposite angles are congruent. So I know angle 1 is equal to 100 degrees. I also know that these together are going to be 180. Because I'm already telling you it's a rhombus, because you know it's a rhombus, that means you know that these two angles are the same. So I could set up an equation that 100 plus angle 3 plus angle 2 is equal to 180. But I know that these two are the same. So it doesn't matter. Both of these could be considered x. So I could subtract my 100, and then I would have 2x, because these are the same, is equal to 80. So x would be equal to 40. So that means that angle 2 and angle 3 are equal to 40 degrees. Now we also have rectangles. And in a rectangle, the special thing about rectangles, we know that the diagonals are congruent, meaning PN, in this picture, PN is equal to MO, because it's the whole diagonal. We do not know what these angles are. That's only in the rhombus. So it's saying this rectangle, PN is equal to this, PO is equal to this. What's the length of PN? Well, again, because these are congruent, because of this property right here, we can say that 7x minus 8 is equal to 4x plus 10. I want you to pause the video and solve that. So we have that x is equal to 6. Now my actual question though is, what is Pn equal to? Pn is equal to this right here. So Pn will be equal to 7 times 6 minus 8, which would be equal to 34. There you have it. That's all, folks. Have a great grand Monday.